So if you did that, 8 is, so if you make it 7, if you borrow 1 from it, how many sevenths is that?
7 sevenths?
7 sevenths.
Okay.
So it's exactly like, so what do we do when we have
I did have it.
this here? Then we have to borrow.
Yeah.
We don't really borrow 1 because if I take 1, that's actually 10.
Yeah.
Then this becomes 12. So when I borrow 1, it's not only 1, it's 7 sevenths. So then this becomes 9 sevenths.
Okay.
Why did you put a 1 there?
That makes more sense.
Because you said 1, so you wrote 1. I love it. So you borrow 1 for the 8, becomes 7 sevenths. Is anybody okay with that? We looked at that before. That's the beautiful thing about 1 is it's anything over itself. So what was wrong with this in the first place, of course?
2 sevenths.
I'm trying to take away too much.
Yeah.
8 minus 2 is 6, but 2 sevenths minus 6 sevenths would be a negative number, which officially, which is kind of weird, officially we don't know negative numbers, according to what we've done so far in the book. They keep, everything's supposed to be whole numbers so far. Okay. Yeah, so one big way to do this is just to borrow 1. And then it becomes, whatever this is that many of those. So then you just add 7 more on top of that. And then you can subtract them, right? What's 7 minus 2?
5.
5. And what's 9 sevenths minus 6 sevenths?
5 sevenths. Sorry, 3 sevenths.
3 sevenths, sorry. I like it.
Okay.
Cool. You guys had a good weekend?
It was a good weekend.
Yeah.
I went to the movies and saw a new horror movie.
Which one?
Antlers. Antlers is about a Wendigo.
Oh, neat. I didn't even hear about Antlers.
It was produced by Guillermo del Toro.
No way. I love Guillermo del Toro. However he says it. You like Del Toro?
Yeah. I saw Danny Elfman this weekend. I don't, do you know who that is?
Sounds familiar.
He did the soundtrack for
There we go.
the original Batman movie, Night
Yes.
Before Christmas.
And you actually saw him like.
He did the Nightmare Before Christmas. Like, I watched the movie, and then they had a live orchestra, and then they had all of the.
Where was that?
It was at the Bank of California Stadium in LA.
Oh, I see. Okay.
So, and then they brought Billie Eilish to do the voice of Sally.
Excuse me.
So, pretty cool.
Well, that sounds cool. All right. I didn't do anything near that cool. I just gave out candy to 2 like a huge influx of kids. I had no idea. I had never given candy out in this neighborhood, and neighbors of mine and I kind of set up at the end of our cul-de-sac, and just kids were just coming. You've seen the suit where they do the like the sparkler, not the sparkler, but the light. They do lines of light. So this one kid came late. It was beautiful. It was dark. He comes up and like, I've never seen this in real life. I've only seen, where it's like just a stick figure. Sorry. So back to questions. Any other questions from homework stuff?
I was practicing on the word problems, just for studying. So I was just practicing on the word problems when I was studying with a tutor. And the one that was, I was not sure if it was going to be on the quiz was in, let me turn that page over. It was about, 24 was a big one.
24 from where?
From 6.2 set A. It had a lot of, like, numbers.
Oh, yeah.
It was like a big chunk we had to take apart.
Sure.
And I was wondering if I got it right.
Well, let's take a look at it. Let's see. This is one about the golf course, right? I believe.
About a wallpaper.
Wallpaper, wait a minute.
24.
6.2A?
Yeah. Or no, 6.2B, I'm sorry.
6.2B, okay. That's my fault. A man measures a room for a wallpaper border and finds he needs lengths. So he needs 10 foot. Dadgummit. Let's get old kids. 10 feet, 6 3/8 inches. All right. 14 feet, 9 3/4 inches. 6 foot 5.5 inches. Are y'all cool with the little lines here? You guys have seen that before, yes or no? Anybody not know what that is? Everybody knows what it is. Okay, all right. 6 foot, where'd it go? 6 foot 5.5 inches. And 3 foot 2 7/8 inches. Good Lord, dude. 3 foot 2 7/8, I think that's it. So what is he trying to do here? What total length of wallpaper border does he need? Blah, blah, blah. Ignore amount needed for matching and overlay. Okay. I like that they put that in parentheses at the end. The problem is basically, if you want to bring up little details, just let it go. So, did I tell you a story about we were doing a problem real quick. Doing an algebra problem where we cut a piece of wood and like one piece is twice as long as the other piece. Does it sound familiar? And I tell you that, the total length of whatever, how long was each piece? So he says, Jeff, you know that if you cut board, about 1/4 of an inch of the wood gets stuck in the teeth of the saw. And I was like, you could put that in your equation if you want to. The rest of us are using freaking lasers. All right, we're just lasering that thing. We don't lose nothing. All right. So I mean, fundamentally, what kind of problem is this? What do I have to do? Of course.
Split it.
Split it. What do you mean split it?
Well, first I learned this technique from the tutor. We can split it. So far we have the 10 feet, 14, 6, 3, and 2.
Sure. All right. So you got the whole part.
Oh, wait. Yeah, not the 3, yeah, not the 2 yet.
All right.
But now we have the mixed number parts. We can split that. So we just have the 6, 9, 5, and 2.
Sure.
And then we have the 3/8, the 3/4, the 1/3, and the 7/8.
So 1/3.
So we just
It's
have to
1/2.
find the least common denominator or least common multiple.
Well,
I
they're
think.
both the same thing.
Yeah.
Yeah. All right. That's one way you can do it. Sure. You could do the total feet and then the total whole number of inches, and then you can add up all the fractional inches. Sure. And then the LCD here is not going to be
it's 24.
bad. No.
It's 24.
No.
It is.
That's a 1/2. I think he said 1/3, but that's a 1/2.
Oh, well,
Yeah.
1/3. Wait.
No, it's a 1/2.
1/2. Oh. Oh, yeah, I
Yeah.
did the whole thing wrong.
No, you got the right idea. That's what matters. You got one number wrong. Who cares? But that'll work beautiful. What's another way to do this? Like, what's already like terms here? Aren't these like terms already? Do you guys see what I'm saying? It's already got the same denominator, but of course when you add them, it's gonna get top heavy, right? Just gotta be careful about that. Or you could do like Andrea did, and you can add these together. You can add the whole parts of the inches together, and then you can just tackle the fractions by themselves. You're gonna end up with a top heavy fraction, but then we already went over how to make that into a mixed number. Now what happens? What else do you have to be careful about? I mean, if you tell me that the answer is like, this is not the answer, but if you say it's 40 feet and 29 inches, how are they going to look at you if you go in to order 40 feet and 29 inches of something? What's wrong with 29 inches?
It would be 42 feet and 5 inches.
Say again?
It would be
Yeah,
42 feet and 5
Yeah,
inches.
because every how many inches?
12.
Every 12 inches is a foot, so that's the extra layer you got to be careful about with this problem, right? In fact, inches are a beautiful analogy to decimals, right? Every time, so if I have 4/10 plus 6/10, what is that?
1.
That makes a whole 1, right? So if I have 6 inches plus 6 inches, that makes a whole foot. Same kind of idea. So inches to feet are sort of like fractions out of 12, right? Where 12 makes a full amount. Yeah, I don't know if you guys are with me. Some of you guys are staring into the distance. It's got me. Okay, all right. I don't know. Is that okay? Is that all right? I'm not sure if I. So it sounds like your approach is correct. You just had that one fraction.
Yeah, it kind of
wrong.
it threw off my whole answer. I'm like, ah.
So like, for example, right here, you would get 15, 20, you get 22 inches. We haven't done the fractions yet, but 22 inches is already a foot and something.
Yeah,
Right,
so
okay.
that would make it like,
So you have kind of two layers of things to be careful about with this problem. I like it. All right. Anything else?
do you think you can, I know this, I know we don't have practice quizzes practice stuff for quizzes, but it kind of would be helpful, maybe?
Well, I mean, all right, so let me just say, does every teacher ever give you practice tests
Yeah.
with answer keys?
No.
Every teacher you've ever had has done it for you?
Well, he has done practice quizzes, but not practice answers, but like, they give us the answers like on an
All right.
online thing.
But the
That's
bottom
fine.
line for me is the quizzes, like the last quiz was pretty nuts and bolts. I make them pretty direct. Just, do you understand the bare minimum of what we're talking about with these last few sections, right? So the quizzes are pretty nuts and bolts. That's what I like to call those, right? Now, I'll give you practice tests, because I have been known to give you some freaky little questions on the test. Yeah, but I'm not gonna do practice quizzes, yeah. That's what the homework is for, yeah. 61A, number who? Number 9. Oh, so again, how do I tell, in fact, what is the procedure to tell how two fractions are related to each other? Like, which one's bigger, smaller, if they're equal? So if I had 7 53rds and 9 65ths, how would I tell if they're equal or if one is bigger than the other?
Sorry, my phone went off.
Oh, sorry. I thought there was a little person running around. Yes?
Cross multiply thing?
Yeah. And again, this isn't doing something to solve something. This is just a method we use to compare fractions, right? So let me see. What? Somebody help me out. What's 65 times 7?
65 times 7 is 455.
I like it. And what's 53 times 9?
It's 477.
Cool.
They're not equal.
And do you see how I put this times this here, and this times this there, right?
Mm-hmm.
So what is the official relationship then? Which one is, of course, this is less than that, so this is less than that. I like it. And how do you do one extra thing that you won't write down in your paper? How would you kind of really make sure that's true? Can somebody tell me? Like, you won't show me you're doing it, but you're going to do it because you're smart, and you're going to check, and you're going to see if it's true. I love you guys. I love you're like, let me try to parse out that sentence.
Yeah.
What would you do to make sure you got that correct? That you're technically not allowed to do until we're done with today's lecture.
Draw the,
No.
divide them.
Yeah, divide, right? Just make them to a decimal and then you can compare them really, right? What is 7 divided by 53? Somebody help me out. Give me the
Seven?
first.
7 divided by 53 is 0.13207547717.
And what's 9 divided by 65?
9 divided by 65 is 0.13846 and blah blah blah.
Okay, so you can tell already that one's bigger, so that makes sense. I like it, okay. So, officially, you're supposed to be able to tell through the methods we discussed, right? Like this cross multiplication thing. You're gonna be smart and go, all right, I'm not gonna tell them to do this shit. I got a calculator, let me just double check and make sure that what I did is right. You guys semi with me? Okay. All right, so yeah, I mean this is the process. All they asked you on that problem was, are they equal, right? Yes?
Will you explain again, when you cross multiply, which number do you put where?
Yeah, so this goes here, bam,
Okay.
bam, and then this goes there, bam.
Okay.
And then the sign is exactly correct. I remember when I was first shown this, and I'm not even talking when I was like a little kid, I'm talking about later in life. The person who showed it to me didn't make that distinction, so it was meaningless. So some of you guys are just sort of putting them wherever, in which case there's no connection. So what's important is the tops stay relatively in the same place. Bam, 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 bam. And then the connection is there. Okay, maybe. Yes?
Can you do, this is just a review practice, but can you do, 5.2 set A, number 12E?
12E?
Yeah.
All right, just a second. Let me just say one more thing about this. Because I just realized if I'm you, I still probably might feel like, okay, why this shit doesn't work? Does anyone feel that way? Does anyone know why this works? When we do this cross multiplication thing, I can see what it is. Does anyone? Okay. Would everybody agree with me that I can multiply both sides of this by anything I want to, except 0, right? Okay. So before we do anything, we don't know what goes here. So I'm going to put like an equal sign with a question mark. Where's my other? Oh, yeah. All right. But I can multiply both sides. If I multiply both sides by a positive number, whatever relationship they have won't change. We haven't discussed this yet. But do you guys remember solving inequalities, and when you multiply by a negative, the inequality had to flip?
Yeah.
Do you guys remember that? Mm-hmm. Okay. I don't think it's come up yet. I really don't think it would have, because we haven't talked about negative stuff yet. But if I multiply, can't I multiply both sides by 65? Yes? Yeah. Why would I do that? Because now that's dead. And then can't I multiply both sides by 53? Yes? Yeah. And then isn't that dead? So doesn't it look like the 65 just came up here? And doesn't it look like the 53 just came up here? So whatever the resultant numbers are, as long as you have those tops in the same place, whatever the relationship at the end is the same as the relationship between the fractions at the beginning. I like it. Yes?
Question on.
Oh, wait, I'm sorry.
Oh, sorry.
I have this one and then I'll come to you.
It was a 12E GCF. I'm sorry, 5.2 set A.
Oh. 12. Oh, this dude. So for example, if I had, what do you got, Jeff? 2 to the 7ths times 5 to the 3rds times 11 to the 4th, and I had 2 to the 5th times 5 to the 4th times 11 to the 7th. This is asking for a who, what now? LCM. LCM, right?
GCF.
Oh, there it is, GCF. I looked at 13. GCF, greatest common factor. So it's as easy as this. When it's all factored, like it's already factored, then the greatest common factor should be really easy to see, because it's all about factors. So what's the biggest number of 2's that they each have?
2,
5 of them,
5.
right? And this is not your problem, correct? I'm just doing a similar problem, right? And then what's the most 5's they both have?
5 third.
And what's the most 11's they both have? Both.
11 fourth.
Both have? I have no idea. So that's the GCF. So
And
what's the shortcut? GCF, you take the smallest power that you see on each base from each number.
And so the LCM, that's the opposite.
That would be the biggest exponent you see. Yeah.
Oh, I gotta remember that.
Because the GCF is all about cutting things down, and the LCM is all about building things up. LCM is almost always going to be bigger than the GCF would be.
Gotcha. Thank you.
Anytime.
Okay, your turn.
Your turn.
2 set A 28.
62A.
Yeah.
28. Oh yeah, this is the one about the 1/2, 1/2 squared.
Yes. I'm so confused.
All right, I got you. We've seen problems like this earlier this semester, believe it or not.
What problem did you say?
This is 62A 28. So the question says find this sum, right? Now one way you could do it is just sit there until you get to 100. Holy shit. What else could you do that we've done before? That sort of with these power kind of things. So 1/2. What's 1/2 plus, what's this?
1/4.
1/4. What's 1/2 plus 1/4?
What?
What's 1/2
1.
plus 1/4?
3/4.
3/4, right? 2/4 and 1, are you guys, is that cool? 3/4. Now what's 1/2 plus 1/4 plus 1?
8.
Do you see how, do you remember doing this?
No.
You don't? Remember the one that said, what's the last digit of 3 to the 157? Do you remember that kind of problem? What's the last digit of 3 to the 157 power? How did we do it? We did a few 3 to the first, 3 squared, 3 cubed, and then we try to see a pattern, right? So what's this? Oops, there. Wouldn't this be 3/4 plus 1/8? What's that? 3/4 is,
It's 7/8.
yes, 3/4 is 6/8 plus 1/8 is 7/8. So it starts at 1/2, then it's 3/4, then it's 7/8. Can you start to see a pattern?
No.
No? Alright, so when it went up to here, what's the highest bottom 4? And the top was 3. So when I only added up to here, I got 3/4. When I added up to here, the highest bottom is 8.
Yeah.
And what was the top?
7.
Holy shit.
7.
Why?
Do a couple more, see if you can verify that the pattern looks to hold. Go ahead.
Thank you.
Sure. Is that all right? You guys okay?
Are you gonna ask us on the quiz to do a number line? It was on, what was it?
Yeah, I could. Yeah, there was a few problems where you had to like add fractions on number lines and stuff.
Yeah, that.
Yeah. I thought she was gonna ask, am I gonna ask, are you okay a lot? And I am, because some of you guys just look beat up, and I'm kinda hoping it isn't me. I'm a math teacher, so I'm used to it being a lot me, so, or at least the class I teach. Anything else from homework? Yes?
5.0 B1.
52B1. Oh, yeah. So, wait a minute, let me make sure, 52B1.
Yeah.
Okay. What was the shortcut to figure out how many factors something would have? So, if I had like 180, for example, I can factor it, start to kind of break it all the way down. So, but I want to know how many, like 1 goes into 180, 2 goes into 180, 3 goes in, so I want to know how long will that list be. So we discussed this before, and of course it's always nice to know how many I should have, because if I don't get all of them, I can tell if I know how long the list is supposed to be. So of course, give me one way to break up 180. 10 and 18. Right? Keep going. 10 is 2 times 5. 18 is 9 and 2, sure. So I get 2 times 2 times 5 times 3 times 3. Is that cool? So I get 2 squared times 5 to the first times 3 squared. Right? Now who remembers what you can immediately do? And we did discuss why this works.
You add 1 to each of the x.
Yeah. And then what do you do with multiply them? Now just to remind you guys, why do I add 1? It makes sense because I really want this to make sense. So real quick, we get 3 times 2 times 3 is 18. Hold on. All right. So I should have a list of 18 factors when I'm done. Now watch, this is kind of cool. Let me put it up here. Isn't this 180? That's what 180 is, correct? And I have no idea how you guys feel about me pretending like there's a biology of mathematics, but I love thinking about that as the DNA of 180. When I put that together, I get 180. It's just like freaking DNA, right? Nobody's telling me DNA is fake or something. I don't know. Watch this. Anything I put together, so couldn't I do like 1, 2 times 2 3s? Isn't that going to be a factor? Of course it is, right? Isn't that going to be a factor of 180 because it's parts of its factorization? What is 2 times 3 squared?
What?
18, right? 2 times 9, right? And 18 is obviously a factor of 180. So, now stay with me. Did I pick any 5s? Did I pick the 5 at all to make that? I didn't have to. So how many 5s could I choose to use? I could choose to use 0 or 1. Are you guys with me? How many 2s could I choose to use? Oh, I love that. It's like a freaking Dr. Seuss. How many 2s could I choose to use?
0, 1, 2.
0, 1, or 2. Do you understand? So that's why we add 1 to each, because this is the number of options for the 2s. The number of options for the 5s, the number of options for the 3s. And we did the whole thing with the tree and all that kind of stuff. Okay, I like it. All right. Is that all right? So there's one level of just conceptually understanding why it works.
Yeah.
And then there's another thing where you just add 1 to the powers and multiply them, right?
I knew the rule. I think I just like wanted to like figure out what the number was and then do that, but I just realized that they already put it like that for you.
Yeah, the problem they have here is already, yeah, you're right. So the problem they have in there is less work. We don't have to do the first step, which is kind of nice. The math books don't normally do that for us. All right, so that's enough questions. See me after you have any more questions. We got to get into chapter 7 desperately. And of course, I think this came up just a minute ago, but what's happening Thursday? Quiz. I like it. All right, so chapter 7, we finally are talking about decimals. And when I say something like decimals are one way to represent certain fractions, right? And the fractions, it should be kind of obvious, the fractions are all fractions whose base is some power of 10, because they fit right into our number system. So just remind me, 4, 3, 2, 0, 3, no, sorry. What place is this? I think I did this before, but thousands.
100.
Yeah, so you did thousands, then you divide it by 10 to get hundreds, then you divide it by 10 to get tens, you divide by 10 to get
1,
so of course this is going to be
10,
tenths, divide by 10 again, hundredths, divide by 10 again, thousandths, yes? And what's the whole idea? This is the ones place, so how many of them do I need before I can roll over into this place? I need 10 of them, of course, right? In fact, every place works like that. Okay, how many? Man, that hurts, man. All right. How many tenths do I need until I roll over into the whole numbers? Yeah, 10. Okay, so every place works like that. This is I have no idea what you guys feel about this. I don't know if you even think about this way very often, but this is a huge thing to make the connection for students, because what will you have done with the students at this point? What would you have done with them in terms of the stuff ahead of the decimal? What would you have done with them here? Well, say again?
Rounding.
Okay, rounding. So I'm talking more like manipulative wise. Remember when we did base 5, did we have the little manipulatives? and we actually laid numbers out, we kind of added them together, did stuff with them? No? Yes? So they've already kind of got that experience of this place needs to go into this place when I get so much of this, right? That idea. So extending it back to the decimals, that's the connection to make. It works the same way if I keep going backwards, right? Okay, maybe. Okay. All right, so that's the basic idea of what decimals mean. What about, how would I read this? Now, you would probably say, we would read this as 4,321.987 or something. But see how that doesn't really flow? We don't say 4,321.987, not normally, yes? So, if anybody's written a check before, I don't know, have you guys written checks? No? All right, I love it. If anybody has, you know how to say this. And, I love it. So this would be 4,321. And, now what is this?
999.
What place is it in?
Thousand.
It's in the thousandths place, yes? Isn't it in the thousandths place? You guys with me? So isn't this 4,321 and 987 thousandths? So if you ever write a check, if you made a check out for, I have no idea why it's $7.14, you never. This would be, we said 7 and 14 cents because it is money, but you would actually write it $7.14, right?
Really?
Yes. You would have this amount up in the corner, and then down here you would say, you're gonna pay that to Jeff, and then below that you would say 7 and 14 100ths dollars. Has anybody, I know some of you guys have seen that, but that's the standard way to fill in a check, because that's the standard way to actually say that decimal, 7 and 14 hundredths. Because again, how do you say, somebody read this for me. What does that say? Holy shit, okay, we already know this. So decimals are fractions. So the same way that we read fractions is the same way we read decimals, because they are fractions. Okay, I like it. Okay. So that's one thing, just how to read them. Another thing, how would I? Let's see. Let me start off nice. See if you guys are cool with this. Maybe this is not overly nice, but let's see.
Is this chapter 7 or chapter 6.3?
7.
So we're skipping 6.3?
Totally.
Oh, okay.
Wait, what? Wait, no, we already did it.
Wait.
6.3 is multiplication.
Yeah, no,
and
we're not
division.
skipping it. I mean, we already did it. Yeah, thank you.
Oh, I didn't know we did that.
Yeah. So the quiz tomorrow, I mean, not tomorrow, but you know what I mean. I didn't make it go all the way up to 6.3 just because I want to make sure everybody had a chance to finish that. So everybody should definitely be done with 6.2 homework by
Yeah,
Thursday.
6.2, yeah,
Okay.
I'm done.
Who's got this? What place does it have to be in?
1,000.
Thousand
This
place?
is tenths, hundredths, thousandths.
0.071.
Yeah, okay, yeah, what she said, okay. 071. Now, we're gonna, anybody, I'm being honest here, anybody have any trouble with that? Anybody?
What happens if it was a different number, not in a hundreds place, but more in
We'll get
tens?
there, we're building our way, we're making our way up there, okay. Now guys, real quick aside note, is this true?
Yeah.
Is that true? Yes. And then what is 70 thousandths? Isn't that 700ths? Yes, you guys with me? So what is this? 0.07. What place is that in? Tenths,
Oh,
hundredths. 11, right? This is whole ones, so this is tenths. 7 hundredths is right there. And what's this? 1,000, there you go. Right? Okay. Maybe. So this is just a kind of another way to look at it, because I sometimes get students, especially back when I taught like math 88, when we had that didn't understand why didn't we put the 7-1 there. I don't know if that makes sense. Right? Why is the 1 in the thousands place? Why is not the 7 in the thousands? Why is that? And so I kind of broke it down like this. Okay, maybe. And sometimes when I point out an issue other people have, I kind of make other people go, well, shit, now I have an issue, but hopefully that didn't happen. Are you guys okay? Are you guys all right? All right, all right. And again, I mean, so like I said before, I've never taught elementary school, but I have taught very low level mathematics. And a lot of the time, the same kind of mistakes of how to look at something would carry over. We're just all human, right? There's sort of, if you're at the same kind of level of understanding of mathematics, you're gonna have the same kind of mistaken takes on things. Okay, so what about, so to Andrea's point, what if I had something like this? What's kind of wrong with that in terms of translating it to a decimal?
It's harder because it's not in the thousands, or it's not over a 10.
Yeah, it's not some multiple of 10 on the bottom, right? When I mean multiple of 10, I mean power of 10. I gotta be careful,
Yeah.
because it is 5 times 10, but it's not 10 to a power. That's better. So what's the easiest way to deal with that?
Multiply by 2. Sorry.
What, I was gonna say 47 divided by 50 is 0.90.
No, okay, stop. We are not using calculators yet. Does that make sense? Right? And dear God, tell me right now that you're not just gonna immediately go to calculators, and you're not gonna be allowed to, hopefully, right? When you're telling kids how to do shit, right? Because the calculator buttons, it does it itself, it's magic. I don't have to know anything, and great. And then we have people that don't understand numbers. Yes?
To answer your question,
Thank you.
original one, I multiplied it by 2 to get to 100.
Yeah. So you can make the bottom 100 easy on this example, right?
Mhm.
So you get
94.
94 over 100, and of course, how do you write that?
0.94.
0.94. Tenths, hundredths. I love it. And again, I am assuming, I really am, that you guys understand most to do with decimals. So what the important thing is as we go through this is, what do you need to address when you're teaching this to your students, right? What could they look at incorrectly? And it's also the big idea about, one thing about mathematics is you always, and I think I said this last time, you always want to tie a new thing into the old thing you talked about last time. Make that connection, right? It always has to be building.
Why
So-
did you multiply by 2?
Say again?
Why did you multiply by 2?
Why was this one easier? Why could I just go straight to the answer? Because the bottom was 1,000. And what's so special about 1,000? Isn't that one of the places in our number system?
Yes.
We have a thousandths place. Do we have a 50ths place? No. Right? We have a tenths.
We have
Hundreds,
a hundreds,
thousands,
and one
10,000s,
tens,
right?
Yeah.
So if I could just make that bottom 100. So sort of like this is reduced, so we unreduce it to be something out of 100. Now it's a decimal.
Oh.
Kick ass. Okay, maybe. All right, so what about this weird ass thing here? I'll give you a little insight. I've never done it the way I'm about to show you, which is kind of neat. I've never looked at it this way before until I saw the way they did it in the book here, to be completely honest. I'll show you the way the book did it, and then I'll show you the way I've done it in the past. But I kind of like this. What is 8? What is 8 if you break it down? Break it down.
2.
2s. Now think about it. Think about it, guys. think about this. If I want the bottom of my fraction to eventually be some multiple of 10, right? Some power of 10. Are you guys with me? I love it. You guys you're awake at least, okay. Doesn't that mean the number has to have a bunch of 2s and a bunch of 5s in it? Or at least some of those, right? Does that make sense? 8 is made up of 3 2s. How many 5s does it need so that I can make it some number of 10s? 3, right? If I have 3 2s, I need 3 5s. So I'm going to multiply top and bottom by 1 over 2 cubed. I'm going to multiply top and bottom by 5 cubed. What is 5 cubed?
75.
It's the road that leads to gross margin.
125.
125. I get 75 a lot, so don't beat yourself up too much, but somewhere in there you got a 15 that leads to 75, right? And then what's the bottom going to be? Don't even isn't 2 times 5, 10?
1,000.
Yes? Yeah, and I have 3 of them, so 1, 2, 3. Let me stop for a minute. I'm trying to read your expressions, and some of you guys,
I'm just not getting, how did you get 5/3?
5/3. Oh, okay, again. What do I want the bottom to be?
You want the bottom to be one of the places?
Like tens,
Like
hundreds, right? I need it to be a 10 on the bottom, 100 on the bottom, some power of 10, right? What is 10 made of? 2 and 5. Does that make sense?
Makes sense, and since you use third, it's gonna be 5/3.
Since I already had 3 2s, I have to give it 3 5s to make it some power of 10, right?
Yeah.
You guys kind of,
Okay,
is that kind of cool? No? All right, maybe cool is not the right word. I'm sorry. Is that semi-interesting? Mildly interesting?
I think it's cool and
Interesting enough for a math course? Okay.
useful.
Useful, okay. And then, of course, what's this? How do I write that as a decimal? 125. I love it.
125.
Tenths, hundredths, thousandths. Bam. So you should write the last digit in the correct spot. Now, the way I normally would do this, we all know what 1/2 is, right? What's 1/2? 0.5. Thank you. And then 1/4 is half of a half, correct? 0.25. So then 1/8 is half of a fourth. What's half of 25? 12 and a half. So there's 0.125. Right?
12
But
and
if
a
I-
half.
Say again?
Where'd you get 12 and a half from?
12 and a half.
Yeah.
Oh, I said what's half of 25.
Oh.
So
12 and a half.
You can kind of ignore the decimal for a second when you're thinking about it, but as long as you put it back in, okay. I like it. All right. So anyway, I thought that was kind of neat. Because I don't get to see a lot of stuff that's like brand new to me. So how would you do this? Using, let's say, the book method, right? If I had 7/16, I got to figure out what that is as a decimal.
Can I just divide that? I was gonna say, can I just divide that? 7 over 16? I could just do by 2, and then you
If
get
I
an
would
extra-
have, if I would have just said, change this into a decimal, right? But what did I say? I said, change it into a decimal. This
Yeah,
one,
have to.
this one. Because again, if you don't agree with this statement that I'm about to make, I'm a little concerned about you teaching children. We need children to understand, we need everybody to understand math without calculators at first, period, right? So I know we got these things and we could just do 7 divided by 16 and it tells me the answer's amazing. But that doesn't give a student any feel for how things work together, right? Okay. But I know us, we would just freaking divide. Of course we would, because we already know all the shit, right? So we would just divide. But these are kind of, has anyone ever seen this? method here?
No.
Thank you. Right? You guys haven't. Isn't it semi-interesting then? I think you guys sort of agree with me there. Okay. Semi is too strong of a word? Okay. So how would I rewrite this to kind of go the same way here? What is 16? Broken all the way down. 2 to the 4th. Right? You want to break down to 2s, because off of 2s I can build 10s. So how many whats do I need?
5 and 4.
I need 4 5s, right? I'll do the bottom. So on the bottom I get 10 to the 4th, which is 1 followed by 4 zeros. It's awesome the way that works. The power tells you the number zeros. That kicks ass. And then the top is going to be something. It's going to be 125 times 5 is 625 times 7. Sorry?
4375.
4375. Okay. And then of course, now I want to write this. You can kind of do this: tenths, hundredths, thousands, 10,000s, and then you just throw the number in. Make sure that you're going to end in the right place. Kick ass. Okay, hit it. All right, cool. I like it. So there is sort of a theorem related to this. I think you can pretty much guess what it is. Let me write this down officially. How did I put it down? If you got a fraction in simplest form, B must equal some combination of 2s and 5s in order for it to become a decimal directly. And let me say it a little bit better. For it to be, for A over B to be represented as a terminal, really, Jeff? What kind of speech impediment are you developing? It would be represented by a terminal decimal. Terminating, let's say terminating. Sounds more extinguished. What's terminating decimal mean, by the way?
It's like not
never
repeating.
ending.
No,
So it's ending.
terminating, so it ends. I like it. Yes?
I have a question for 2n, 5m.
Yes?
Shouldn't it be the same exponent? So it'd be the same.
No.
variable?
What I want you to understand is, for example, will this be able to be made into a decimal that's terminating? Yes, because it has 4 2s.
Yes.
And then I can give it whatever number of 5s it needs.
So
once
any
you,
five, any
so
five.
if n is less than m, it needs more 2s. If m is less than n, it needs more 5s. Does that make sense?
Yes.
So this is the fraction we're given. This is the fraction we're given. And then based on what I've got on the bottom already, I can see what do I need to give it. So the bottom has to be only 2s, 5s, or some combination of 2s and 5s. So if I have a 7 on the bottom, is that going to ever be a non-terminating, a terminating decimal? No. In fact, if you do 1 divided by 7 in your calculator,
Get like,
what do you get? Let me see if I remember. I think it's this.
0.142857.
Okay. I've got my division by 7 memorized. That's, ooh, wow, Jeff, living that life. Okay. It's just because it happens often enough in probability that it just sort of stuck in my brain. All right. This is interesting to me because I've never thought about it like this, which is really intriguing to me. I've never really stopped to think about this. It's kind of nifty. So we're all learning. We're all learning together. Okay. Oh, can somebody tell me real quick? There's no questions on this. Can somebody tell me real quick, why does 0.7 equal 0.70? How can you show a student?
0 is a not a significant digit.
But is that Is that
That's
good enough
chemistry.
to explain it to a student?
No.
No.
It's like a placeholder, right?
Okay, sure, sort of. It would actually,
Zero has no value to this.
what does 0.7 mean as a fraction?
Seven
Seven
over
times.
10, but it could also be like 70 over.
Yeah, what does
100.
0.70 mean? What place am I in?
7 and 100.
And of course, this would reduce to,
Oh.
there, that's the way to show people, right? Now, if you've ever taken, real quick side note, if you've ever taken any science courses, has anybody in here ever heard of significant? You know what about significant? I think in science it's figures, in math it's digits.
We use
Significant figures.
significant digits. I think for us, I was in high school chemistry, but it was intermediate. We just used both.
Okay, sig digs or sig figs, right? And if
We
you've
use
never
sig
taken
digs.
science, if you don't know what that is, don't worry about it. I just want to see if any of you have heard of it. So in science would treat these as something different. They are the same number, but like if I said, I measured this to be 0.70, and somebody else says I measured it to be 0.7, I'm more confident about how I measured it. I dare to go out one more place and say, I know it this far. No? Okay, that's enough of that, sorry, it's science. Okay. So, if I wanted to know which one is bigger, how do I compare decimals? So which is bigger? What you got, Jeff? 0.14 and 0.7. We normally put the 0 just so we don't lose the decimal. Poor little decimal dude.
It's 0.7 is bigger.
Why? Isn't
Because-
14 bigger than 7?
Well, it's the same thing as fractions when the denominator
11.
is bigger.
But can't you see your student looking at this?
Yes.
Teacher, man, what the shit, teacher? Hopefully your student, what the shit, teacher? 14 is bigger than 7. What is this? What is this? So you try to stress to them that one way you can think of it is money, right? This would be 70 cents. And this is 14 cents. So obviously, that's bigger. So it's the idea that you can't compare until you've put them on the equal footing, right? And of course, when you're talking about decimals, I think somebody else just said this, you can represent them as fractions. And then when we did fractions, we said, how do I compare them? We could cross multiply, but if you can make the bottoms the same, that's better, isn't it?
Mm-hmm.
So then you can just say, it's just like making the bottoms the same, and then I can see that's bigger.
Couldn't you also divide 14? Wait. Oh, never mind.
Okay, I won't mind. I was gonna say, you could cross multiply and do all that
No,
stuff, but
I
you don't
would-
have to.
Yeah.
Yeah, okay. All right, I like it. I like it. I like it a lot. All right, what do you guys think about this here? What method could you use to do this? What, Jeff? Put something up here. I mean, what strategy do you think could be employed for this that we've discussed in the past? Instead of just starting to put them together and carrying shit.
Adding the 1.7 and the 4.3.
Yeah, what's special by these?
They make a whole, hole.
Hey,
All right.
don't you have, wait,
Make a
the
whole.
parentheses messed me up, dude.
What's wrong with the parentheses?
Because you know how you usually do it, but since this is associated. one
I
of
love
those-
it. So if I have
It's
a
either-
especially when I have a single operation, I can ignore,
The parentheses.
yeah, because then I can associativity, commutativity. So I could do commutativity and then associativity, and I could end up with this. Yes? Commutativity, associativity, bam. So we normally don't even show that. So if I have if I have nothing but addition or nothing but multiplication, let me be careful. The ones for which associativity and commutativity work, then you can just start moving shit around without a thought. right? So when I sneak in there division and subtraction, those shit, they don't have associativity connectivity, so you gotta be careful. And of course, this makes 1 and 4 is 5, 7.7.3 is another 1, so that's 6. 9.2, bam. So let me show you something. We're starting to get a little bit further in. Let me show you one thing that we actually don't truly have. I'm gonna pretend like we do right here. This is sort of a poor man's version of what I'm gonna talk about. I guess it kind of summarizes gross fun. Let me pull this down. You guys ready? You guys down there? I want to show you a couple of things. One thing in real life and one thing virtual. Here's the exciting part of the class. Oh, I guess I'll turn you around. There we go. So, I was thinking about giving these to you, but it's just a little bit crazy. The actual, so, hopefully, your school, wherever you end up working, will give you these blocks. Now, how do you think these blocks relate to fractions or decimals? I mean, this looks like a flat that we used before for a 10 by 10, right? How do you think this relates to decimals? Well, didn't we do a process? What if you had a rectangle and you broke it into 10 parts, right? Each part is 1/10 then, correct? What if you broke that up into 10 parts again?
That'd be even smaller.
So how much is this worth?
Just that, 0.01?
No, yes, 0.01. That's 1/100. 11. You guys with me? So,
And then the whole line would be 0.1.
yeah, in reality, so these are just, these kind of suck. And you want to get ones that you can kind of like fit into so they kind of click, sort of like Legos, right? Oh, kids would go, you know, holy shit, Legos coming. So I just got these that sort of sit on here and slide around, they kind of suck. But if I fill up, everybody just wait for me to do this. Oh, jeez. Oh, this is the best thing ever. I would pay money to watch this. All right. All right. Do one more. Get on there. Okay. All right. So what does that represent?
0.1.
Yeah, that's 1/10. And again, this is a nice visualization of it's broken into 1, 2, 3, 4, and 10 columns. So one complete column is 1/10 of the picture. But then you remind them, each one of these is 1/100th. So what does this really represent? 10/100ths. So 10/100ths equals 1/10. Continuing this visualization we've been doing with fractions, yes? Maybe? Okay. So what is this then? What is it? What is it?
0.01, no. 0.15, wait.
0.15, 1500ths, right? Each one of these is 100ths. And now you just put 15 of them down, yes? So that's one way to get there is there's 1500ths. Or you could say, this is 1/10, 0.1, and this is 500ths, 0.05. When you put this together, it's 0.15. Now that's a little ahead of where we are right now, but you can see how you can use this to build the idea of addition. So everybody kind of with me, right? So that is 0.15. So if I wanted them to do a problem like, what's 0.15 plus, on the other side of this, they could build something else. I don't know, Jeff, there we go. What is that? Yeah, that's 8, right? So if I want to do 0.15 plus 0.8, sorry, 0.08, keep myself straight. 0.15
.23.
plus 0.08, so now they can actually physically move this. So 5 of these would go there,
Yes.
right? And then you got this extra 3. Doesn't this kind of feel like what we were doing before with the base blocks, right? The longs and the flats and the whatever? Yes, maybe?
This reminds me more of the fractions with the square, the little shapes.
Oh, the shapes. I got you. That's exactly how I was trying to say it in the first place was 10s and then 10s. Yeah, I love it. Cool. Whatever works. The whole idea is it connects with stuff we've done earlier, right? Okay. So let me show you this version here.
Would you teach, sorry, not really, it's kind of related to this. Would you teach percentages within the decimals? 'Cause that-
Yes, I mean, the
so
very
it-
next thing you would do, maybe not the very next thing, but pretty soon after decimals, you bring in percentages. Yeah, for sure. Because all percentages are
That.
our decision to rewrite decimals in a way that makes more sense. So if somebody's like 0.005, instead of 0.5%, I have a better feel for 0.5% than I do 0.005, right? So percentages are another layer of stuff that humans made up on top of decimals. I don't know if you guys are with me or not. No? You guys, how do you guys feel about percentages in general?
Multiply, move the decimals.
Hate them, wish they didn't exist?
I prefer them over, I mean.
We're gonna really like it when we talk about them. All right.
I'm not gonna, I did not like that part.
This part?
Yeah, that part, no.
What about it?
It's just, I'm like, how? How?
How what? I need to know exactly.
Like, where did you
Holy
get
shit, I
with
moved
the
those so much.
numbers? Or I don't know.
Where did I do the what now? Sorry?
I just got so lost on this.
All right.
I mean,
One
what's the
thing to
flat
realize-
supposed to be? 1,000?
All right, let me do this. Do you remember how we talked about, how we talked about multiplying fractions? Like if I had to do 1/5 times 1/3. So the way we did that,
That's it.
the first way we did that, go ahead, sorry.
The first time we did that was times the 5 and 3 and
No,
to
no,
find
no,
the
no,
final
no,
fit,
no,
it'd be
no.
15.
Nope. First time we did this was visually.
Oh, visually.
Here's 1/3, correct?
I guess, yeah.
Okay, pretending like I cut it evenly, so, you know. And if I take this 1/3 and I cut it into 1, 2, 3, 5 cuts, and then take one of those, stay with me now, right? Do you remember doing this? We did this. How much does that represent of the whole thing then? Well, there's how many pieces? Of course, there's 5,
5,
3.
3.
How many pieces are there?
1, 2, 3.
No, don't count. Isn't there 5 and there's 3? So how many total are there? 5 times 3, right? 15. And so this would be 1/15 of the whole picture. Okay.
Yeah.
And of course, this visual immediately leads to what you were saying at first, correct? But you want the visual. Yes? You always want the visual to ground them in reality. We're not just doing this abstract shit that has nothing to do with real things, correct? Okay. So, this blue thing here, isn't it 1/10?
1/10.
Watch. Didn't I take a block and I broke it into 10?
Yeah, you broke it into 10.
Alright. And then I broke each of those into 10, yes? Isn't that 1/10 times 1/10? Isn't that 1/100th? So each of these
100.
spots is 1/100th. So what is, this is 10 1500ths. Because you got 15 blocks, and every block is 1/100th. So isn't this 1500ths?
Yeah,
Isn't that 0.15?
yeah.
Okay, and what's this?
4, 5, 6, 900. 9 over 100.
8. Right, 8. Yes?
8. Yeah,
Yeah.
8. Yeah, because
So then, we can do exactly like we did before. What do I get when I add 0.15 to 0.08? I can move these over,
You move them over.
and I get 0.23.
That'd be 23 over 100.
Beautiful, yeah, 23 over 100.
Then that would be.
Or looking at it as a pure decimal, 0.23.
0.23, yeah.
Yeah, and this is neat. Some of you guys are on your calculator, some of you guys are on your phone. Maybe you're on your calculator too. What does it mean? Let's see, I lost what I was gonna say. Damn it. Oh, if I ask a student to add, well, they would get this correct. What would be wrong if I ask a student to do 0.15 plus 0.8? What do you think they might tell me? What mistake could they make? 0.15 plus 0.8.
They're gonna just add
8 to 15, you get 23, which is not what we just did. We just did 0.15 plus 0.08. And then they kind of line up as the way they're supposed to. All right, maybe. So this kind of leads in the whole discussion of how do you line things up so you can actually add things together. Okay. Let me see. So let me show you this on the computer real quick. So this is a little underwhelming, but it's not that terrible. I mean, I can kind of, and what this is really doing is seeing which one is bigger. Yes, you guys see at the bottom there? So you can kind of change this out and see when, so they're equal there. And now this one's bigger than that one, and visually you can see it's got more squares. Okay, so this is basically just the same thing as my little square, except they got green. This one's a little more interesting, it's a little more colorful, because I could increase the number of colors I want to use.
Yeah.
It's kind of nifty, right? So I can turn these back to white, and I kind of get a running counter of what fractional piece they represent here. So what's interesting is right, now you stopped working. What happened here? There we go. Right here, I'm at 41 over 100, but if I turn this dude off, I'm at 2/5. And of course, what happened? This was 41 out of 100. Now I should be one less, so I should be at 40 out of 100, but of course that just reduces to 2/5. So again, this one manipulative leads to how to add, how to subtract, how to reduce, all this different kind of stuff. Good, maybe. Okay. Yeah, okay, that's all I want to show you there. Yes, I believe, yes. No good videos today, unfortunately. All right. So let me ask you a couple things you should already know. For example, what is 3/4?
0.75.
0.75,
love it.
like 75 cents.
75 cents, I like it. 3/4 is 75 cents. We just earlier did 1/8, yes? So 3/4 is 0.75. Anybody remember what 1/8 was?
125.
125, I like it. So what's 3/8? So 1/8 is 0.125. What's 2/8? When I just add another 0.125? Yes? So that would be 0.25. Remember this how we got it from 1/4? We cut that in half to get 1/8, yes? So 1/8 plus 1/8 is 2/8 is 1/4. So how do I get all the multiples of 8s? I just keep adding 0.125. So if I add it once, I get to 2/8. So that's 0.25. Add another 0.125 on, sorry.
Could you multiply 0.125 by 2 if you're doubling it?
Yeah, sure, of course, same thing.
Okay.
So 0.125 is 0.25, that is 1/4, or 2/8. If I do it again, I get 3/8, yes? So that's 0.375. I keep going for the eighths, yes?
Will you mark us down if you don't put the zero in front of the decimal point?
No, but I kind of said this earlier, why do you think it's good form to put the zero in front of the decimal?
So you
So it
don't
doesn't get
lose
lost.
it.
So you don't lose it, I like.
But I sometimes forget about the zero.
I don't blame
just
you,
wondered.
it doesn't make it wrong, it just makes it less conventional.
Right, so big.
Like, look
you
at what I
can't
just
lose
did.
it.
I didn't put a zero there, right?
Yeah.
So, hold on, I didn't put zeros over there either. Let's see, oh yeah, what's 1/5? Well, let's do this, what's 1/10? 1/10, that's easy, right? So what's 1/5?
0.2.
That's gonna be twice that, yeah, 0.2. And then, of course, 2/5, 3/5, redfish, no.
Wow,
What happened?
it's crazy.
Crazy shit. I just decided I want to show you one other thing real quick. Does anyone know what 1/3 is as a decimal? 3. I like it. So, real quick.
That,
Are you guys semi-cool with what's going on here so far?
Yes.
And before I do my weird little side thing, let me just tell you, if I had to do 0.125 times 80, and I had to do it by hand, right? What can you immediately do based on what we just did to rewrite this? What is 0.125? What's a better way to write it for this problem?
Right.
1/8. Why is that better?
Because 80 is,
80 divided by 8 is 10.
Done, yeah?
yo,
Go. Okay,
I'm just taking a picture first.
sure, yeah. I'm taking a lot of pictures. Anyway, so there's a whole little section in this section that talks about equivalent fractions and decimals, right? So you can kind of interchange them as to which one is easier to work with. So I would hope all of us are very familiar about what to do with something like this, right? What's the quick way to do that?
divided by 2.
Yeah, 0.5 is half. So I gotta do is half of 980. Maybe, yes. So we should already kind of do that.
So wait, how did you get, what's 0.5 again?
Just think about
same
it.
thing as divided by 2.
0.5 is a half, yes?
That's 1/2.
Because it's 5/10, which reduces to 1/2. Like,
980 divided by 2. Oh, okay, yeah, now I get it.
let me show you one little thing. Let's see. Alright. So I want to show you something kind of cool about, if I have a fraction that I don't know what it looks like as a decimal. Right, if you know, does somebody know, don't say it. Does somebody know what 1/9 is? Don't say it, don't do it in your calculator, just watch. I just want to show you this real quick. I know we're talking about terminating decimals, so let me just show you this. So do I know what 1/9 is as a decimal? No. So what do we do in algebra when there's something I don't know?
Variable.
Call it, I love it, call it x, or any variable you want, right? And, well, I'm actually, oh, Jeff, you crazy fool. You're crazy. All right.
Yeah, crazy.
I did this backwards, hold on. It's like I'm telling a joke and I started the punchline.
Yeah,
That's good.
that's crazy.
Good shit, good shit.
That's fun.
Let me start. I'm gonna give the answer away, but it's too bad. Okay, what does that mean, real quick? What does that mean? Repeating, I love it. So it's
But
like
also
one,
remind me of this,
say again, sorry?
the Roman numerals and the T.
Oh, shit, yeah,
Okay,
don't think
anyway.
about Roman numerals, this is just our stuff. This just means, that little line on top doesn't mean multiply by 1,000, it means it continues forever, right? This sucks, because could I write that as a fraction then if it never stops?
No.
Because then I don't know, if it stops somewhere, I could just count and I can tell how many zeros go on the bottom, correct? That'll tell me what place it's in. This thing never stops, so it's 1 followed by an infinite zeros, holy shit. So you might think, no, if you've been paying attention, you already know the answer is 1/9, but oh, but you might think, looking at this, there's just no way to write this as a fraction. But again, so let me do what we did earlier. I'm gonna call it x, because I don't know what the shit it is as a fraction. Yes?
On the same topic, I just have this question, what would pi be in fraction form? Is there even a fraction for that?
If you found out, you would be the most famous in the math community,
I don't like
which,
math, so
which
that's
is
okay.
basically saying you would be relatively unknown, but still.
Yeah.
To a lot of us geeks, you would be well known, right? The most famous person in the math community. I don't know that person, okay.
Yeah, hello, math bitches.
But yeah, pi has no observable pattern that we know of yet. And we have calculated it to the stupid number of places. I mean, we just let computers crank it out, and we're still like, there's no pattern. So you got math people kind of going insane. All right. So what sucks about this is it's repeating. Now watch this, watch this. This is kind of cool. What is 10 times anything? What does that 10 times something do? What does it do to the decimal?
Another zero or
Oh,
What's it do to the decimal?
moves it.
Moves it over one,
Yeah.
yes? Okay, so wouldn't this become then 1.111 forever? So what do I get if I subtract what I started with? Right? Wasn't that what x is? That's what x is, and that's what 10x is. Are you guys, no? Again,
No, what?
again, I don't know what 0.11 is forever, so I'm gonna call it x. I'm just gonna call it x. 10x then is that times 10. There's no getting around. If x is this, 10x is 10 times this. Yes?
Mhm.
So I know what x is, and I know what 10x is. Can't I subtract them if I wanted to?
Yeah.
Of course I can. What's 10x minus x?
10.
No.
Wait.
10x's minus 1x.
9x.
9x, there it is. What happens here that's really kick-ass? How many ones cancel? An infinite number! What's the only one that's left? 1 minus 0 is 1. These kill each other.
yay.
That's a little harsh.
Divide by 9. Yeah, my math is pretty violent. You probably shouldn't teach it the way that way. So look at, Mama, numbers are killing each other. What happened? I'm sorry. You guys? No?
They're also eating each other because 7, 8, 9.
What is the
This is
9x
true.
over 9 equals 1 over
Oh,
9?
okay, okay.
What is that?
This is just assuming you remember your algebra. How do I solve that for x? Because again, what was the thing I want to know?
Oh,
I want to know what this is. I want to know what that is as a fraction, and that's what x represents. So if I solve for x, I know that is what this is.
Oh.
Now here's the next cool shit. What's 2/9 then? If 1/9 is 0.11111, what's 2/9? 0.2. So what's 3/9? What's 3/9?
Oh, it's 1 over 3.
Yeah, but what is it? Just tell me.
3.
3. Which of course is 1/3, but 3/9 is 1/3. Okay, thank you. All right, that makes me feel a little better about today, because today most of you guys look like, oh Jesus,
It's not Halloween candy.
what the
Yeah,
shit's
it's
going
not-
on?
God.
I'm tired.
I
Yeah,
understand.
I-
You're on the down slope after that. I understand.
It's November.
I try to pace myself a bit,
No, it's
so
like-
I'm relatively okay. You gotta do is you gotta take a hit of sugar every now and again just to kind of even yourself out.
I woke up at, I couldn't fall asleep until 2 a.m. in the morning, and then somebody called me like around 8 o'clock.
See, that's why I think they should make the day after Halloween a holiday.
Yeah.
Desperately has to happen.
Yeah.
Anyway, all right. How much time we got? Oh, we got plenty.
But the day after, it was a Monday.
Yeah, that kind of sucked.
That's probably what.
So here, let me see if you guys we should reverse. We're paying attention a second ago. What would this be?
One fourth of that.
Yeah, 0.25 is 1/4. What's 1/4 of 488?
It's 1.
Oh, ooh, oh.
1.
Yeah, 1, 2, 2.
I
122.
said that.
I got you. All right,
Can
I
I
like
use-
it.
Can I use my calculator for dividing? You know, 488 divided by 4.
All right, let's see. Hold on. I think I had an example of division later, but I might as well do it right now. What about if you had, 600 divided by 0.25?
A fraction over a fraction, beautiful.
Yeah, no worries, right? Isn't this 600 divided by 0.25?
Yeah.
Like this? Right? Let me put the 0 in there so things look a little cleaner. What is 0.25? 1/4. And what is 600 divided by 1/4?
What's 600 divided by 4?
605.
Divided by 1/4 is times
4
4 over 1.
What is 600 times 4? Is that 1600?
No, 6 times 4 is
Oh, it's 24.
24, and then add the zeros.
Oh, okay.
So division, you can still use the same kind of thing.
5.
Maybe? No? You guys all right?
Yeah, I'm starting to get this part, yeah.
So even if you divide by a decimal that you know the fractional equivalent of, that will still help you because you know division is just multiplied by the reciprocal, right? Okay.
Yeah.
The multiplicative inverse thing.
Yeah, multiplicative inverse thing. I love it. Let me think. Darn it. It had some. Oh, yeah. The one little thing, I don't normally show like my students in algebra all of these, but I definitely show them this one. Whenever I divide by 0.5,
Multiplying by, no.
yes?
Is it the same thing, multiplying by 2?
Yes. Divided by 0.5 is divided by a half, which is multiplied by 2. So that's why dividing by 0.5 is easy as shit. Right?
Did we already do that?
Say again?
We already did that problem.
That same problem?
Well, we did the 0.5 times is the same thing as multiplying by 2 problem.
Not good.
Maybe.
We did?
Maybe earlier this semester, but not earlier today. Not that well, anyway, I don't know if I could trust my memory.
Nah, dude.
We talked
Didn't
about it.
All right, I love it, as long as it's happened at some point. Okay. Oh, couple more things, guys, and then I'll let you out of here. And yeah, I'm sorry, today is kind of like lecture heavy. That's probably why you're all like, I got a lot of shit to just throw at you. And then next time after the quiz, I said next time, we're not leaving. That's like
Oh, darn.
it's like a trigger. Next time, okay, no.
It's like telling a dog to go.
I know,
walk.
it's like, yeah, exactly. Walk. Next time we'll have some, you said walk again. Next time we'll have some, worksheet to work on together. I got a few more things to throw at you.
Thursday not going to be here.
Okay?
The testing.
Oh, you're gonna miss class? No.
Yeah, cause
I
Thursday,
thought wasn't your appointment like later after class? I thought.
it's after class.
Yeah, it's after class.
Yeah.
But you're gonna be here, right? Why wouldn't you be in class? Doesn't make any sense. It's
Because
just a quiz. I'm still
yeah.
gonna lecture after the quiz, so don't miss class.
the thing, yeah, but I'm not, the quiz, you guys are gonna do the quiz during class.
Sure. So you don't have to come on time then. You can come a little bit later.
Yeah, but then you guys get out at 2, and my quiz doesn't start until 2:45.
I desperately want you to understand. You can come in, you can sit down, you can just not take the quiz. Other people will take the quiz, you just sit there, you won't take the quiz. Or you can hang out somewhere else and come, and I can come tell you when to come in, right? I just don't want you to miss lecture, I don't want you to miss any worksheets. There's no reason for you to miss all the class. Does that make sense?
Oh, God.
Unless you really want to.
No, it's just that,
And you
it's
can
just
tell
that
me-
it's just my driver, Miss Elizabeth, and I already told them this, that that I'll do the quiz at home at 2:45.
All right, well, if you
But
have to
then-
miss class, you have to, but you should understand that quizzes don't take the entire time. We do lecture after quizzes. Yeah, it's tests that take the entire class time. Yeah, okay. Now I gotta, oh yeah. How would you do, some of you guys might know this already. You guys know what form that's in?
Yeah. Scientific notation.
Scientific notation, kick ass.
Chemistry.
Let's do it a different way,
No.
because I want to.
Okay.
Oh, God, please no.
What is 10 cubed?
It is 1,000.
Yeah, it's 1 followed by 3 zeros.
1,000.
I like it, right? Now we're basically doing scientific notation. We're just kind of slowing down, remembering why it works.
Because
What happens when I multiply anything by 10?
add
The
the
decimal
zero.
moves over
Oh,
once,
that too.
right? So how many 10s am I multiplying? 3. So I'm gonna move the decimal over. Yeah, so another way to look at this, let me do this, really break this down. How does this look as a fraction? You guys know 3.75, what would that look like?
3 and 3/4.
All right, I'll take that, 3 and 75.
I said 3 and 3/4. Would that work too?
I wanna keep it in terms of tens. Do you see how that would work really well with 1,000?
Yeah.
All right, you guys, and now watch this. Are you guys cool with this? It's the same thing.
I don't like it. I wanna go
Yeah,
back
there.
to Bible.
Why is that the same thing? 100 times 3,
Yes.
300 plus 75, 375. So you could actually just put anything like this all over 100 in this case, right? Because it is the same thing. Now what happens here?
Cancel.
Oh, I lost the zero. Sorry.
Sometimes.
How many tens cancel? There's like
One
2.
time.
Are you guys cool with that? 2 zeros cancel? Because that represents 2 tens. And so what's 375 times 10?
3,750.
Oh. Right. 307. I love it. Okay. I love it. That's awesome. I'm not laughing at you, I'm laughing near you. And of course, just because this came up earlier, what if I had 53.17 divided by 1,000? So you could rewrite this.
3 and 17 in thousands?
Say again, sorry?
Wait, hundreds. Wait.
Yeah, all right, so this will be 5317 over 100, correct? And this is times what?
1,000.
No, this is
Wait.
divided by 1,000, so it's times 1 over 1,000. Do you guys like that?
Yeah.
Oh, cool, all right. So we get 5317 on top, right? And how many zeros do we get on the bottom? 5. Which is cool because, sorry?
I definitely did not do it like that, and I don't know.
No, don't worry. I mean, I would really highly doubt that if I just gave you this problem, that you would actually do it this way. But you can see, do you see how it's, and then I want to come back and show you how you should do this problem. The nice thing with the zeros on the bottom, it tells me what place I'm supposed to be in. I'm supposed to be 5 places in. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 5317, you can start from the end. And so, so that's a nice way to kind of make sure you end up in the right place.
Oh, shit.
Shit. So what's the right way to do this? Every time I divide by 10, I move the decimal back. I'm dividing by 3 tens, I gotta move it back 1, 2, 3 without another 0 in front was exactly what we got. Like, it's kind of freaking warm in here, isn't
A
it?
little
Is it
bit.
just me? It's normally just me, but it's a little bit warm in here. Oh yeah, all right.
Wait, how
Is it
many
just-
times do you move the decimal place back when you divide it?
So, real quick word about just that idea. Real quick word about just that idea. If I have a decimal and I multiply by 10, the decimal moves over by 1. Let's really see why that's true. What is 0.02? It's 2 over
100.
100. And so when I multiply by 10, do you see how it,
Yes.
okay. So the shortcut, it really is just a shortcut. I move it over by 1, so the answer is 0.2.
Yeah.
So if I multiply something, some decimal by some multiple of 10, some power of 10, let me say it like that. All I have to do is count how many zeros, 1, 2, 3, 4, and then I move the decimal. 1, 2, 3, 4, bam. I like it, right? And of course division just moves everything the other way.
Okay, never mind, I know what I did wrong. I had the decimal place in the wrong place at first.
Oh shit. All right.
Now it has to be that.
Last thing. And then we'll head out. actually, before we talk about estimation, we'll do a side note, rounding. That's how I make the last thing into two things up. I find that almost no matter what level of math I teach, I always have at least 5 people that forget how to round, right? I don't care if I'm teaching Calc 3. I'll have somebody who's like, "Does that become a 5? Oh shit, what's happening?" So of course, if I wanted to round this number to the 10,000th place, 10,000ths, gotta put my lisp in there. What is the 10,000th place?
9.
The 9 is in the 10,000th place. So of course, how would I round this then?
0.
Just near 1,000, 10,000?
7.
7, 9.
Okay, so the next number is a 2, so I don't take it out, right?
What happens if the two, the last,
I'm with you.
the other
Ready?
place was a 5
All
or
right,
higher?
this is the first level. What if it would have been this? And I have the same question, round it to the nearest 10,000ths.
Would it change, would the 7 become an 8 and the 9 would be a 0?
Yes, because now you're looking at, so you're always, so if this was a 2, right? This was a 2, this would go up to 3, but I prefer to look at it, it would go up to 73. Is this closer to 72 or 73 when you look at this? It's closer to 73. Are you guys kind of with me now? Yes? All right. So then this, if I make it a 9 again, does that make more sense? Is it closer to a 79 or closer to an 8? It's closer to an 8. And in this case, I might put the 0 there just so that my teacher knows. I know that's the 10,000th place. Yes? Okay, maybe. All right, so if I'm going to estimate stuff, in order to estimate, I need to know how to round, right? So if I had to estimate uh, 1.89 plus 0.15 plus 2.76. I'm not even telling you, I just want to know an estimate. So what is what's a good word for this? The crudest, the roughest
Do you want
estimate?
round to the nearest whole?
I didn't say. What is the roughest estimate you could do? Round everything to
Whole place.
whole place, right? So what would this be? Then my estimate would be what? 2 plus
I guess that'd be 0.
0, good. Plus
3.
3. I love it. So my estimate would be $5.
Yep.
Right? If you want to get a little more precise and say estimate it to the 10th place, then what would this become? 1.9 plus 0.2 plus 2.8, and then of course, I'm going to do those first because that makes 3, so I get 490. That should be a little more precise than that, but the level you estimate is dependent on how important it is to be more right.
Science.
Oh, sure. I didn't believe it was science. All right, that's enough. That's it. Thanks for making it through, guys. Really sorry that I made today worse. Thank you.
You got, okay, questions?
Actually, yeah. Wait a minute, Madison, are you out there? Oh, I just barely caught it. Jordan, you back down?
So my quiz is at 3:45, but they said I have to take it at home. But I don't get home until 4 or 3, my driver.
Oh, I see. So you did come.
I did.
So in the future, for quizzes, you've got to realize you don't want to miss lecture. You have to space things out so that'll work. So you don't miss lecture, but you can still take the quiz, right?
Yeah.
Okay.
So.
So it's okay. You can catch the video, right?
Where do I find the video?
I just
On
have
Canvas.
the other half, but
I did put a link on Canvas, I believe.